Okay, we're looking at page 101 in the workbook for Math 20, which is on operations on radicals. And so today we're looking at adding and subtracting radicals. So let's start off with your calculator actually, and just a little mini investigation. And so this is asking us to investigate which of the following radical statements are true, and circle the ones that are true and place a single line through the expressions which are false. So understanding, of course, that your calculator, if you were to enter in square root 2 plus 5 root 2, your calculator, most of the graphing calculators are not going to spit out 6 root 2, rather they'll give you a decimal approximation, and then you'll just need to enter in 6 root 2 and figure out what that decimal approximation is. And the idea is, just like with an equation, does the left side equal the right side? And so what we find with the first one, and I can even show that first one to you, let's do that. Okay, so you can see I've entered in root 2 plus 5 root 2, and we'll hit enter. We can see the decimal approximation is 8.485 approximately, and then let's take a look if we enter in the right side, which was 6 times the square root of 2, and then enter. We can see that the decimal approximations are the same, which means that root 2 plus 5 root 2 is the same value as 6 root 2. Okay, so that is a yes, so we'll circle that one. And so just go ahead and hit pause, and we'll come back and look at that together then. Okay, and so when we test all of those examples out, what we recognize is that 1, 2, and 3, those were true, and 4 and 5 were false. And so just paying a little bit closer attention, so why is it that 1, 2, and 3 worked and 4 and 5 didn't? And so that's that investigation piece. So what patterns do you notice? And so if you take a look, 4 and 5, for 4 we've got 2 different indices or indexes. We've got the square root and the cube root, so that's why that one doesn't work. And then for example number 5, we've got different radicands, so cube root 3 and cube root 2. So the same index, but different radicands. And so that didn't work. Whereas in all of examples 1, 2, and 3, we've got the same index, so square root and square root, or cube root and cube root, square root, square root, square root, and the actual radicands were the same. So we've got root 2 and root 2, root 5 and root 5, root 8, root 8, root 8. So our rule then is that we can add or subtract like radicals similar to combining like terms with polynomials. Oops. Okay, and so with like terms with polynomials, if you recall that the variable and the exponent had to be the same, and then we just combined the coefficients. So it's exactly the same thing here. So if we have root 2 and root 2, then that stays the same, and so it's like having 1 root 2 plus 5 root 2 is 6 root 2. 4 cube root 5 minus 7 cube root 5 is 4 minus 7 is negative 3, and we hold on to that cube root 5. So it's no different than if cube root 5 was x, I had 4x minus 7x, we'd know that it's negative 3x. No different if we've got three terms that we're adding together in our expression. So 5 root 8 minus 2 root 8 plus 7 root 8 is then we're going to keep that root 8, and then 5 minus 2 is 3 plus 7, 10 root 8s we have then. Okay, so let's take a look then. Part C, so 8 root 7 minus 3 root 7 plus 15 root 7. So those are all root 7, so we know that's the same. 8 minus 3 is 5, plus 15 is going to be 20 root 7 then. For number 2, we've got 18 times the fifth root of 10 plus 12 times the fifth root of 10 minus 7 times the fifth root of 10. So again, we know that we're dealing with the fifth root of 10, and 18 plus 12 is 30, minus 7 is 23 then. So 23 times the fifth root of 10. Looking at number 3, 5 root x minus 4 root x. So then again, our radical stays the same, root x, and 5 minus 4 is simply 1. So I can write 1 root x, or root x is the same thing as well. Okay, take a look at investigation number 2. So it says use a calculator to verify that the following statements are true. So similar to what we did earlier, enter in the left side and find out what your decimal approximation is, and then enter in the right side and see that decimal approximation and just verify that they are in fact true. And so just hit pause for a moment and check that out for yourself. And so what you hopefully did find is that they are both absolutely true. And does it appear to contradict the rule that we wrote? Yeah, it absolutely does. Yes, because these ones have different radicands. These have different radicands. So again, the radicand is the number underneath that radical symbol. Okay, the index is the same though still. Okay, so let's take a look though as to what happened, because it doesn't actually change the rule that we had. So if we remember back to root 8 has a perfect square factor of root 4. So we could rewrite root 8 as root 4 times root 2, or again, root 2 plus, and root 4 is the same as 2, so root 2 plus 2 root 2, so that's 1 root 2 plus 2 root 2, which is in fact 3 root 2. And then for the second one, root 12, again, has that perfect square factor of root 4, so we can have 5 root 4 times root 3 plus 6 times, and the perfect square factor of root 48 is going to be root 16, and it's root 16 times root 3. So here we really have 5 times 2 root 3 plus 6 times 4 root 3. So that's 10 root 3 plus 24 root 3, which is our 34 root 3. So when we look at those previous examples that they showed us earlier, it's not actually changing anything. We cannot add radicals that have different radicands. What we should do then is what this investigation is showing us, is that we should always first make sure that they are in simplest mixed form, so that you have removed all perfect square factors, and that way you will know if you have like radicals. Okay, so taking a look here then, in order to add and subtract radicals, must be able to expressed as like radicals, and like radicals means having the same radicand and the same index, so it must be both then. Okay, so let's take a look then, class example number 1, and so they're asking you to add and subtract in these cases, and you notice across the board none of these examples actually have like radicals and like radicands, so our first step is to take a look and see if we can make them into like radicals, and if they can't, then they can't be simplified further. We can't add or subtract. It's no different if I asked you what's 3x plus 2y. These are not like terms, so we're done. That is as simplified as it gets. So it's the same thing. We're going to take a look. If we've got root 80, then our perfect square factor for 80 is root 16. So root 16 times root 5 minus root 20 is root 4 times root 5. And so root 16 is actually 4, so 4 root 5 minus 2 root 5 is equal to 2 root 5. And for a question like this too, if you're looking at root 80 and saying, oh my goodness, I didn't realize that root 16 or 16 went into 80, then that's fine. You remember, you can always start smaller as well. You can take a look at root 80 and say, hey, I know that 4 goes in, so root 4 times root 20, so then that's going to be 2 root 20, except root 20 has another factor of root 4 times root 5, and so then that's 2 times 2 times root 5, or 4 root 5. So it's just like reducing fractions again, so if you don't see the largest perfect square factor, you can certainly work your way down. The other thing that you can do is also start with a smaller one. So with that root 20, if you know already that that's going to be 2 root 5, that's a good place to start, is to say, hey, if I was to be able to combine them, which isn't a guarantee, but a good place to start would be to say, hey, what is it that is going to be times root 5 that will give me root 80? And that might be a clue as to where to start as well. Okay, so let's take a look at B with the cube roots then. So cube root 80, so again, this time with an index of 3, I'm looking for perfect cubes. So perfect cube that goes into cube root 80 is going to be 8, and cube root 8 times cube root 10 plus, and with the cube root 270, largest perfect cube is 27 times, again, cube root 10. So again, so we can see that we're going to get that like radicand, and so that is a clue if you're not sure where to start. So cube root of 8 is 2, so 2 cube root 10 plus cube root of 27 is 3 cube root 10, and so that would give us 5 times the cube root of 10. Okay, so just hit pause and you can come back and compare solutions with me. Okay, so root 27 is going to be root 9 times root 3, and so root 75 is root 25 times root 3, and root 147, again, that's a tricky one, but a good place to start anyways is looking at the fact that the other two terms have a root 3, so we can say, hey, how many times does 3 go into 147? And of course it ends up nicely that that would be root 49 times root 3. So you can see I've taken that extra time to write in 7 times 3 because root 9 is 3, root 3, and then 3 times 5 root 3 plus 2 times 7 root 3. 21 root 3 minus 15 root 3 is 6 root 3 plus 14 root 3 is 20 root 3. So there will probably be a time when you can skip some steps, but common mistakes that people make is that they're thinking lots of steps in their head, and I've seen 63 root 3 instead of 7 root 9, or 7 times 3, so just be careful with that. You're not ever going to lose marks for showing extra steps, but especially if that can save you from making some errors. Okay, take a look at class example number 2. So it looks pretty complicated there with all of those fractions, but don't let that intimidate you. I'll work on A with you, and then you can try B on your own. So we're talking about square roots. So again, one of those things that I had suggested to you guys before that might be helpful is just making a list of all of your perfect squares. So it's one less thing that you have to be going through your brain in terms of what are possible factors of those numbers. And so just having those handy, I don't think I need to go any higher than that. So looking through those, so 108, the largest perfect square factor is going to be 36. So then I've got negative 5, and that is root 36 times root 3 plus 3/4, and that's going to be root 4 times root 2 minus 5/4, and root 48, remember 16 goes into 48, so root 16 times root 3 plus 1/2 root 25 times root 2. So again, if that 108 had you stumped, then start with some of the other ones that you know for sure, and they give you an idea of where you can go and what might be like radicand in the end. Okay, so then we've got negative 5 times 6 root 3 plus 3/4 times 2 root 2 minus 5/4 times 4 root 3 plus 1/2 times, times 5 root 2. So then negative 5 times 6 is negative 30 root 3, and 3/4 times 2 is going to be 3/2, or 6/4, which is the same as 3/2 root 2, minus, and 5/4 times 4 is just simply 5 root 3, and then plus 5/2, because that's 5/1, of course, root 2. So we've got the two pairs of like radicals, and so 3/2 root 2 plus 5/2 root 2 is going to be 8/2 root 2, and 8/2 is just simply 4, so we've got 4 root 2, and then minus 30 root 3 minus 5 root 3 is going to be negative 35 root 3, and there we have it. Okay, so give B a try on your own, and then just hit pause and we'll come back and compare. So you can see that just along the side here on the right side, I took a moment just to write down a few perfect cubes. Just again, it's something that I can quickly look at as opposed to trying to think through the factors and divide all at the same time. And so it's a quick reference. So cube root of 64 right off the bat, I can see it's a perfect cube, and that is 4. So we've got 4/8, also known as 1/2. And then cube root 375. 125 is a perfect cube, so that is the same as 5. So we've got plus 2 times 5, cube root 3, and then minus, and cube root 54, we've got 27 that goes into 54, so cube root of 27 is 3, so then we could say cube root of 27, that's 3/3, which is just going to be 1, so really that just leaves me with 2 times cube root of 2, minus, and then a factor of 24, so cube root of 24 is going to be 8, so cube root 5 times cube root of 8 times cube root 3, and cube root of 8 is 2, so once again that's 2/2, which is going to be 1. Okay, so that leaves us then with 5 cube root 3. And so then we have, in terms of like terms now, we just have our cube root 3. So this is 2 times 5, or 10 cube root 3 minus 5 cube root 3. So that's going to give us 5 cube root 3. And so that's when we combine these two together. And then that leaves us then with minus 2 cube root 2 and plus the 1/2. Okay, excellent. And so to check any of these, I mean, this one would be a little bit more difficult to do because of the fractions perhaps, but remembering you can always enter it into your calculator. The calculator is just going to give you the decimal approximation, but if you find that for both the original expression and then your simplified expression, then those should of course be the same. Okay, let's take a look at class example number 3 then. So it says find the length of x. So as first as an exact value and then as a decimal to the nearest tenth. So as an exact value, then we're looking at keeping it in radical form. So the first thing that we want to do is to simplify those radicals. So we have 8 root 2 plus 2 root 12, and so that root 12 can be further simplified. So 8 root 2 plus 2, and then we're looking at root 4 times root 3, or 8 root 2 plus 2 times 2, root 3, or 8 root 2 plus 4 root 3, and so that is for this full length right here. And so 5 root 27 then is the same as 5 root 9 times root 3 minus 4 root 18, or root 9 times root 2. So then that's 5 times 3 root 3 minus 4 times 3 root 2, or 15 root 3 minus 12 root 2, and so that gives us this little portion right here. So what we know again is the fact that in order to get x, so if I was to say this is A and this is B right here, then we know that B plus X equals A, or X is equal to A minus B. So if we write that out and X is equal to A minus B, then we know that A is 8 root 2 plus 4 root 3, and we want to then, of course, subtract 15 root 3 minus 12 root 2. So the mistake that we've made right here is that, technically speaking, we're only subtracting the 15 root 3, but we actually want to subtract all of B, and so this whole expression, 15 root 3 minus 12 root 2, is B, so we need to put brackets or parentheses around that, those two terms that make up B. And so that means we're essentially distributing in that negative. So we could rewrite this as 8 root 2, 8 root 2 plus 4 root 3 minus 15 root 3, and then minus a negative is the same as plus 12 root 2. So now to clean that all up, combining our like terms, so 8 root 2 plus 12 root 2 is 20 root 2, and 4 root 3 minus 15 root 3 is going to then be negative 11 root 3. So that is our exact value. If we want to find the decimal, then that's where we need to take out our calculator, and then, whoops, I need to minimize that, just bring it to the side there. So let's take a look. So we need 20, and that is, whoops, let's quit out of there. So again, we've got 20 and root 2, and I just need to arrow over to come and get out of that radical, minus 11, and then square root 3. And so we can hit enter, and there's our decimal approximation for that, which rounded to the nearest tenth is about 9.2 units then. Okay, and that doesn't give us a specific unit, so we'll just say it's in units. Okay, excellent. So that's the end of addition and subtraction. Please let me know if you have any particular questions.